Welcome to our webinar series on cloud deployment best practices. It is our great pleasure to have all of you joining us today. My name is Desmond Chan, co-founder and CPO of Aquila Clouds. Today we have a very interesting topic presented by Professor Prasad Calyam from University of Missouri. Professor Calyam is our technical advisor and he has been advising us on building our cloud management platform. Before we start, just a few bookkeeping items. We are recording this webinar and we'll send a link to the recording after the webinar, so stay tuned. And if you have any questions, please feel free to type in the Q&A pod and we will address your questions in the Q&A session towards the end. So that said, I would like to introduce Aquila Clouds to you. Aquila Clouds offers an AI-based SaaS platform that provides full control of your cloud deployments across costs, performance, and security best practices. We enable the paradigm of continuous monitoring and continuous optimization, what we call CMCO, using our application intelligence and automation capabilities. We provide you with a closed-loop approach that gives visibility, recommendations, and automated actions, so that the cloud operators and all of the cloud professionals can be orders of magnitude more productive. Highlights of our cloud management capabilities include multi-cloud operations management across AWS, Azure, GCP, and DigitalOcean, and cloud resource and cost optimization, and 360-degree service level management from infrastructure to application to the overall service level. Our recommendations are a result of analyzing all metrics from infrastructure to applications to the overall domain level metrics. And we also have what we call a cloud advisory capability. And this also includes cloud migration assessment and advisory functions. Our recommendations are based on machine learning practices and also statistics. So we do quite a lot of heavy lifting in the backend for analysis. One of our major capability is automation for actions, and we give you alerts and also reporting. If you want to know more about Aquila Clouds, please come to our website at www.aquilaclouds.com and note that our name is Clouds, plural. And now let's get into our webinar. Professor Calyam is going to tell us more about his research in OnTimeURB, which is multi-cloud broker framework for creation of secure and high-performance cloud-based applications. Without further ado, please welcome Prasad.
Yeah, so here we go. So today, the topic is on this project called OnTimeURB. It's a multi-cloud broker framework, and our goal is that we can help cloud-based applications to securely and in high performance way connect to multi-cloud platforms. And there are very interesting challenges. This is a very timely topic for many applications today, and any application today is looking for any cloud resource that can serve all the needs of the users and the scale of the users and diversity of the capabilities the providers give keep varying every day. And so there's a need to really be on top of which clouds we are using, and just like we use many operating systems, we're all every day using many clouds. So having a more clever way to manage how we pick the clouds for our processes is a very important problem. So that's what we're trying to discuss in this project, and that's what I'm going to talk about. I am an associate professor in computer science at University of Missouri, and this project is actually a very much a team project. I have excellent collaborators in many disciplines. Trupti Joshi, who's in bioinformatics, Isa, who's actually from usability perspective, helping us, Saptarshi, who was one of my postdocs, now is a professor in Central University of New York, and Tim Midlukup, who runs research computing. All of them are working with me very closely on this project that's funded by the federal government, the National Science Foundation. And we've been working on this for the last 3-4 years, I would say. And again, there are many wonderful graduate students helping us in these projects. Ronnie, my PhD student, started this all, I would say, and then it's been continued with many others like Ashish and Sen, Samaikya, Kanupriya, Min, Somya, Ramya, Mauro, and Yenmis, and many of them I think are on this webinar also. So this presentation is really a collective effort from all of these great people I've been working with. And my premise for today's talk, starts with the idea, as I said, any application today is data intensive. We're, having this deluge of data. Data is everywhere. We're getting data from so many sources, and we're processing it. And our need is to really get on-demand resources to do this. And cloud obviously provides us the rich diversity of resources, APIs, pay-as-you-go kind of services to really tap into all these ecosystems where we can build hybrid clouds. We can have our own cloud, we can have public clouds, we can build community clouds that are targeted to certain communities of interest. And we are also seeing this really interesting rise of programmable technologies like SD and OpenStack and all those things that help us to very seamlessly federate with a number of cloud providers. So if you look at how applications have evolved, in the good old days of computing, we would design a system, build security on top of it, right? We would say how many users are going to use this application. And once we set up all of these things, then we kind of say, okay, who's allowed to use this? So we think about security as sort of as an aftermath, right, of the development. Whereas if you look at today's systems, security is very much integral in how we design the system in terms of performance or management or cost-wise. Security is a very important aspect, and more importantly, if it's in the cloud, security probably is our foremost concern, right? And then we kind of go about who's going to use it, how are they going to use it, when are they going to use it, and what are the loads we need to worry about, and issues that might come up. So security has become very integral, and that security concern also could be taken to the extreme, right? So here is a kind of a nice cartoon that shows security is more important than usability, right? And that's why we have a usability researcher on our team kind of telling us not really, right? If you really just go all the way in terms of security, log into the computer by staring at the sun, correct? So that's not really practical. That's not the way we want to do things. So we want to really balance security along with our user experience, with performance and usability. And a good balance is sort of what we're looking for in today's cloud-based applications. And so with that, what I would like to do is really get into my talk in a little bit more detailed way. I want to give you two application use cases. They come from a little bit academic side, a little bit healthcare side also. So a bioinformatics scientific application and a health information sharing application. And we want to kind of motivate why we would need multi-cloud brokering, and what are the challenges and what are the kind of opportunities that we can then kind of build a automation framework around. So that's this middleware that I'm going to talk next, which is the OnTimeURB, where we want to look at the security requirements, performance requirements, find a way to formalize these requirements to cloud capabilities, and provide users with choice to really go find the right cloud for their problem. And so we'll show you also some results from our implementation on both these applications and show you how we're sort of leading some ideas in this space. So getting into the applications, one of the things that we're doing today, if you're any enterprise, is you're getting data, you're going outside your domain, right? You're going outside your traditional borders of control. So you're putting it into another application infrastructure, or you're taking it to another cloud infrastructure outside your enterprise. And so we are going into these sort of cross-domain resource usage scenarios, and we have different expectations as we go outside the domain in terms of security, performance, sharing of this information or data processing, and the life cycle can be, kind of complicated today, given you're doing a lot of high throughput computing where we're task driven. The processing can happen in many places, and sharing also is done at every life cycle stage. And if you are, anybody in an enterprise worrying about security, you can see that, for example, our university will say, well, you should not be really trusting these other institutions in terms of protecting your intellectual property, or think carefully before you go out, right? If you're going outside your domain of control, we strongly discourage you to do it. Talk to us. Security is an issue. So there are basically some concerns even from the user side. What if my data gets deleted? What if my data is shared with others inadvertently? So there's all these concerns. So going beyond our control domain is always a little interesting decision we make. And some of the applications that actually thrive on this sort of federated resources, are these two example applications I'm going to talk to you about. And one is, as I said, a scientific application which has a lot of processing, a lot of data transfer involved in the processing, and we call these sort of applications as science gateways. So essentially, the users are not computer experts; they're biologists or people in agriculture, and they need a lot of computation. They have a lot of data to process. All they need is simple interfaces like a web portal or simple API-driven services that easily perform a lot of the complex processing of this data. And Tripti Joshi, who's one of my collaborators, has been working on this project for several years. She started the project called Soy KB. It was so successful, she has sort of scaled it for other plants and organisms, which is called KBCommons. And this is kind of how the kind of cloud transform setup looks like. So there are many sources of data that are pre-processed at University of Missouri, and this large data sets are sent to the clouds through very high-speed networks. And we are using, in this case, Cyverse, which is one of the community clouds funded by National Science Foundation. And they have abilities to do basically Pegasus workflow kind of management systems on the back end. So yeah, here is the idea I was talking about. So there's a lot of this processing that's again given to users to look at remotely, right, through web portals and things like that. And some of the concerns of processing such sort of workflows is we have a lot of genomic data, and there's always this fear. We also want the cloud providers who are processing this data to have synergistic data security policies. And so if you look at, for example, an example offering of the different cloud providers, each of them have different capabilities for doing compliant processing, right? If you're trying to do FISMA or HIPAA and other things. So for example, in this graphic, we can see, Google is probably not your best cloud platform if you want to FISMA compliant stuff, but you could do it with, Amazon or Google, or Azure can be used if you're doing HIPAA kind of compliant workflow. So there's always this problem of the synergistic policies of the providers also helping in making sure that if you're worried about some of the privacy issues in your workflow. And this is more really how the problem is more interesting, that it goes beyond just security, right? The cloud providers are giving what we call as R specs or resource specs, so they're giving you functional criteria to be satisfied: storage, networking, CPU, GPU, software stacks. Whereas as users, we are trying to optimize a lot of quality specifications. They're called Q specs, which are related to performance, and security specifications, which are related to security. And our cloud-based applications really thrive on this sort of non-functional criteria from a user perspective, right? We want good security, great performance, great agility, but very low cost if possible. So we want to optimize these things, and the providers are not necessarily worrying about those things, and they try to help you, but it's on the user's end to figure out how to balance all these non-functional criteria and optimize them for their workflows. And so that can be really overwhelming, right? So if you're a user, you have a lot of choice in the cloud, And essentially, if you're a manufacturing company or a sort of a business that's not really in the cloud technology field, this is a little bit overwhelming. How do I pick the best solution? This is going to be very difficult for me to figure out how to configure my resources. How can I address all the security issues in terms of policies and other issues related to agility and cost, right? So that's the dilemma. And another use case, which is here I talk about in a healthcare perspective, is more on data sharing. So here we are looking to federate data sets and obviously also do processing, right? So in the bioinformatics use case, we were more interested in the processing of the data. Obviously, there's a lot of sharing of the data afterwards. But in the healthcare data, we are trying to get data from many places, do the processing, and then share the data. So it's a little interesting twist to the use case. But again, the data can come from many sources with many policies and compliance issues. And then you have to really figure out a way. If somebody asks for the data, how do you check the compliance before you give the data for processing, right? Before you give it to a trusted computing workflow, and how you can move the data also securely in the cloud as you do this processing, and then people can use it to visualize. And there are, in the field of precision medicine, many use cases that really are coming into shape because of data analysis and aggregation, right? So the whole idea of precision medicine and AI in healthcare is based on this premise that we can have all these data sets that are continuously updated, and we can have these knowledge bases that we can look into and, for example, find better cures. And one of the data sets that we use is the Cerner Health Facts database that University of Missouri hosts, and there are 60 million patient records, billions of transactions between doctors and patients, and we want to really make that data access and sharing fast and secure. And people who are in healthcare really can benefit from this. So this is my friend Pooja. She's an oncologist. If she had the right information at the right time, just before she goes and prescribes a treatment for a patient, that could mean life and death. It could mean a lot of cost of care, better quality of recovery for the patient. So there's a lot of stake that can be considered when a decision is made, and data-driven decisions can really help provide better cure for patients. So the problem of these kind of potential applications is again, in the cloud, trust is a major issue. If you are putting data, and if you're a data custodian, you're worried about people copying your data, deleting your data, and issues related to loss of integrity also, right, of the data. So there's a lot of resistance to giving data to people, even though they're probably eligible for it, right? So I have a neighbor here who's a cardiologist. He wanted to actually do some research on the COVID crisis related to cardiology, and regularly their office sends a lot of data to this database, and he decided, well, I'll ask the database provider for some data, because I've been contributing data to that provider. Now I need some data for my research. I'll ask them. And so they said, fill out a form, and he fills out a form, and they basically say, well, it looks like somebody else is already doing what you asked for the data set for, so why don't you come up with a better idea? And the background for this sort of a scenario is that the data custodian, again, has a lot of governance that goes with the access to the data. So if the data is given to my neighbor, he has to really have an IRB, has to be tracked, the auditability, accountability, assurance of the data has to be really done on the provider side, which is a lot of work. So they don't want to do it till they really have a very good reason to engage in sharing the data. So that's basically the concern, is this loss of value if the sharing is not done properly. But again, from a user perspective, I don't mind going through all your hoops, but then if you take a long time to give me the data, I lose my opportunity to, for example, help my colleagues in the cardiology community deal with this COVID crisis we are facing, right? So there's a lot of opportunity issue. There's a balance that needs to be happening. And so the way this governance happens is what's called the honest broker framework, where data is requested and there's a governance committee which pretty much is manually done today, and it takes several months before data is given. And even if the data is given, the security requirements or the performance is very much not optimized for these trusted computing frameworks, and it could take several minutes to run very small analysis, or a little bit complex analysis can take several days to run. And the policies also can be very tricky. So when you ask for data, most enterprises, if they have data or resources, they set up policies by committee, and you could have these words where people say restricted and somebody will say sensitive, and also somebody might have a policy that is 5 pages, or somebody else will have 150 pages. Again, the policy by committee is also an issue. So we don't have a really good way to make sure once we leave our domain or we are going cross-domain for data or for computation, are we aligned in terms of the expectation for the workflow? And so that's another challenge. So hopefully I have motivated you enough to say, there are actually major challenges for a user today when picking a cloud in terms of the performance, security, agility, and cost. And it's a little overwhelming if they have to do it by themselves, trying to figure all of these things by hand. So are there ways we can do these in a little bit more automated way? We can look at standards as a way to bring the alignment, and can we formalize those requirements at the beginning and then match them with optimized resources in the cloud. So I'm going to talk about how probably we could try to come up with an automation solution. And our solution essentially begins with this understanding that the policies, the resource provider specifications, the R specs, the performance requirements, right, the specs, and sort of security issues from the user side as well as the provider side are all like these gears, right? And there's friction amongst these gears. And we need to really find a way for all these gears to function in a way that the users are happy at the end of the day. And that interconflicts can be resolved, and you can do a set of steps to really achieve what the users are looking for. So we could collect the requirements from the user in terms of security performance in some very clever way. We can find a way to do the compliance checking, find a way to find the interoperability between different cloud providers for a workflow, and then you can align the workflow capabilities to the cloud capabilities to meet the user's requirements of performance and security. And then as we are doing that, we can optimize these multi-cloud resource brokering. And this is our kind of overall framework, how we do it. We're looking at from the left top, a user using a federated identity access management framework to get into the application, and the brokering essentially is looking at getting the requirements in terms of performance, security, generating these S specs, Q specs that can be standardized, and there can be automation. So we use some natural language processing, some standard documents from NIST and others to sort of align the policies, and we can then create these resource allocations that use some machine learning to figure out which are the right choices of resources, and we can then reserve those resources, provide monitoring, and then have the user run their workflows. And so this challenge, as I said in the beginning, requires you to collect these requirements. And users are not always very much aware of what the requirements are. Right? So if you ask a user to fill out a long questionnaire, they might not really give you the right answers because they might not have the expertise to give it, or maybe they don't really understand your terminologies also, right? So that's where we have been working on coming up with sort of a knowledge interface system that can talk to both novice and expert users to collect their preferences. And so it could be very simple questions that we ask. Also, it could be a set of questions that actually will be different based on our understanding of the profile of the user. Are they an expert, or are they a novice? And depending on their previous answers, we could be asking follow-up questions that are different every time, right? So this is what is sort of a knowledge interface system. And you can collect these requirements. Same thing for a data access also. You can have some questions, and potentially you can even have a chatbot. That's what we're working on. Our chatbot's name is called Vidura, that we're able to use to get these sort of workflow requirements so that we can start doing some automation and management of the workflows. And once those requirements are obtained, we split them into data requirements, auxiliary requirements, and we use this NIST, SP 800 guidelines to come up with these sort of high, moderate, low kind of requirement tags. And then we can actually look at from a security perspective, use this NIST FIPS 200 guidelines to basically say, here is where the security requirements are going to be aligned. And we can then do a compliance checking, right? And we can take these, as I said, different policies from different organizations that could have different keywords, and we try to find a way to map them to this high, medium, low, right? And we can actually look, for example, in this health facts Cerner database policy. We can look at how they would require some server compliance before the data is actually hosted for sharing, and then we can try to do those checks to see what's the risk of a particular data request tied to the data being provided. And from a cloud provider perspective, again, we can, as I showed you from this table earlier, that you can have different interoperability issues between different cloud providers. At the end of the day, you can kind of do this checking and come up with a set of candidate cloud providers who you think are compatible or incompatible, and you can use a number of factors to come up with this sort of a matrix. So you can take the requirements, find some alignment through any methods that are relevant, and then ultimately what we want to do is give the user a choice. It's a recommendation, and the user is in the best position to optimize their requirements, right? So we talked about the user trying to optimize cost, performance, agility, security. We call them the PAX factors. So we could come up with, for example, 3 choices to the user. So a red choice, which is, do it all by yourself, right? It's going to be cheap, but you have to do all the heavy lifting to secure your workflow, to make it cost effective, etc., etc. And then the green option is your best option. It's going to be expensive, but we will do everything for you, right? And it will really work with all of the requirements that you're asking for. And then the gold option is somewhere in the middle, right? So we want to be able to, again, use these requirements, come up with a set of, we call them templates, that essentially have the topology of how the resources are set up, and maybe it has some benchmarks also associated with the topology, so you can see what would be the expected performance from such a deployment. And you can have interfaces that actually help the user navigate through these choices. You can say you can use these cloud providers, it could cost you so much. Here are your gold options, green options, red options, and the user is then more informed to pick what they want for their workflow. So another sort of way we want to make the decisions also is allow the the owner of this, for example, data, to also look at the alignment and say, do I see this as a low risk or a high risk or a medium risk data request, and do I really need to go through a whole set of manual approval, or can I do some automation, right? So can I, for example, look at a security strategy where I use a combination of different things, that I encrypt, I notify the owner, and maybe that's enough than actually going through a full manual request, right, and approval. So then we can automate that part, or we can say, oh, you have access only to so much of the data, or you can only access this data at this time. So you can come up with these policies for access than just saying we'll look at it in a manual process and let you know in a few months, right? And so the risk and performance balancing, right, can be helped by these sort of alignment methods. So that's sort of the ideas of how we could go about dealing with this diversity of choice, policies that are diverse, requirements of the users that are diverse, and find a way to come up with some brokering techniques. And how it looks like in the implementation is sort of what I'll talk next. Here is our OnTimeURB implementation for KBCommons, the bioinformatics workflow. And as I said, we have a user giving requirements through a knowledge interface system. There's optimizer that is using knowledge from the cloud providers, knowledge from previous workflows that were successfully completed on them, and it's matching the user specifications to these template recommendations, right? The gold, green, and red. And then once the user picks the specification that fits their requirement, it then goes off and does the workflow management in the cloud, automates a lot of the processing, data collection, and sharing through web portals. And then the users and the providers have the ability to monitor and make changes to the workflow. And in the recent times, we've been looking at how we can incorporate a lot of machine learning methods to make this choice more intelligent. So we have worked with a couple of different techniques. One is a sort of a K-enable, a KNN kind of a scheme. Another one is this machine learning based optimizer. Ashish has been working on this. And we have come up with some experiments that actually can take a bunch of different workflows. So we have these different workflows from KBCommons we've developed that range from something very simple to something that's very complex, and sometimes even we use a combination of these application requirements to set up these workflows, and we are able to configure them on a federated set of resources. So we use Pegasus to create the workflow pipelines, HTConda to do the scheduling, and so on and so forth. We have Cyvers as a cloud, and we can look at different cloud providers also to match the resource requirements to the cloud capabilities. And so it looks like this. So we have these workflows. They're split into the different sizes that can be mapped to the workflow management system. And we schedule them on different resources, and we find the templates that are eligible, and based on what the user picks, we're able to go run them on those resources that are remote. And the experiments look something like this. So we can come up with a scenario where for a particular request, you can have 3 or more options for you to do. So in this figure, we're showing if the user, for example, picks the MU, the private cloud, they get priority. So obviously their execution times will be very high. And we've seen, if you look at the policies of TAC or ISI, TAC would be ideal in terms of the security posture. So it aligns better with the requirements of the user. Whereas if you really went to ISI, you get the best of the both worlds. You get better performance as well as better security for a given set of requirements. So the brokering can really help figure these things out for the user without having to really go through a manual process or sort of trial and error to find, where should I go compute. And some of these things are, as I said, data driven, and that's what the templates do is they learn basically based on previous experiences. They can predict which will be the right location to move the data, which will be a place where the execution times can be significantly lower. So we're kind of constantly learning these things, and then we can use them in future recommendations depending on what type of workflow comes in. It's a simple workflow or a combination of a set of complex and simple workflows. And from a matching set, like I said, we've been doing the optimization, and we've looked at a KNN scheme and a more machine learning based optimization scheme. We've taken these different workflows, as I said, they have different complexity, and we've matched them to the cost models of different providers. And we have shown that we can optimize better. A KNN scheme basically takes a vector of the requirement from the user, looks into the knowledge base and says, I think this is a red solution, this is a green solution, this is a gold solution based on the distance of a solution to the requirement. That works pretty well, actually. We've shown that that was one of the earliest state-of-the-art techniques. But with machine learning optimizers, we can do much better. But again, if the cloud interoperability is a constraint, the optimizer, again, has limitations also, which is kind of natural to know. So that's shown on the right side of the graph. And what we're working today on this is trying to go down this route of the user knows better, or the user's satisfaction is sort of what we want to ultimately accomplish, what they're trying to optimize, and not necessarily what's a particular cloud's capabilities, right? So we're trying to use this idea of fuzzy logic to better find out user preferences, so we can find what is really a workflow performance that the user is happy about. Ultimately, it's about user satisfaction of the workflow's performance, and we want to customize the solution to meet that particular user's needs. So in the healthcare data sharing side, we are again a set of experiments and a system that we've implemented. So it looks more like this. It's a semi-automated honest broker. The data can be brought from on the left side, you can see from many data sources, and then the broker is doing those 4 steps I talked about, which is collecting the requirements, finding the alignment, doing the compliance checking, and then allocating the resources and optimizing it, right? So the compliance here will be more on the HIPAA and IRB, which is a requirement for human subject data access, right? So it's checking all these compliance, and there's a risk assessment involved in this alignment process, as I said, for a data custodian to approve access to the data. And then there's a computation engine, and all of that is presented to the user in a very easy to use user interface. And we want to achieve this idea of auto assurance, auto auditability, so this manual process of the governance can be made more fast and secure, right, through these sort of cloud-based applications. And so the same steps, like I said, we do. We will take the requirement, categorize them into performance security requirements, check with the compliance with some natural language processing schemes, come up with a score based on a trust framework, aggregate that score with the compliance score, and then the data custodian has these risk levels, low, medium, high, and or a score between 1 to 10, and they can then make their decisions on what would be the way they want to allow access to the data. And in the recent work we've done on this, we've been basically, again, using a chatbot interface to make it easy for the requirements collection, so that the users and the resource providers or the data custodians have a more, easy semantic dialogue, right? So they don't get lost in the terminologies, and it's easy to understand exactly what the user is asking. And then we have a trust framework that's based on blockchain, where we can have this auditability more easily delivered across different hospitals or different data providers and different kinds of users from different organizations. So blockchain is another nice implementation on cloud we're working on, and the data again has to be brought in and put in a model that can be easily visualized at the end of the day. So in conclusion, what I've been trying to explain to you is there is a benefit in aligning security and performance, and it requires some formalization that we've been doing that seems to show it works. And then once the requirements are formalized, there are ways in which we can do these resource allocations that are both jointly done with performance and security factors. And there are methods where we can use machine learning and optimization and these sort of automation frameworks for workflow management, or even these risk assessment methods and platforms like blockchain to help the decision makers run their workflows more effectively, right? And this approach, again, for now we've built it for healthcare and bioinformatics. We see the potential for it being useful for many other application communities. And so in conclusion, I want to say that it's overwhelming today for a user with all this choice. Our methods of using multi-cloud resource brokers hopefully can help the users and provide the required success they need in hosting their cloud applications. Thank you. So I can take some questions if somebody has some questions.
If you have any questions, feel free to put in the chat room or just feel free to talk. If you can raise your hand, I can.
Yeah, I have my email also if you need me to contact me after this talk, and there's a website for this project also.
So the email of Professor Calyam is listed on the screen, and also there's a website right there. So, Professor, you're saying that this has been you have been focusing on healthcare and bioinformatics, and there are other spaces that you think this broker system can be of use. Like, which other industry are you thinking?
So we worked a lot, and Ronnie is on the call also. So on manufacturing is another industry we worked with. Again, they have a lot of modeling and simulation. There's a lot of data that they want to move because it has a lot of CAD designs. They reconstruct the physical prototypes into virtual prototypes, and they do a lot of testing. And they work with customers, who are basically these large OEMs who have these project lifecycle management systems that all these models need to fit into. And so they have to ship VMs between each other. They have to monitor the performance of these computations because time to market is a critical issue, and productivity is a very critical issue. And all these manufacturing companies are all not very big, and they're all not like Procter and Gamble. There are a lot of small, medium businesses wanting to use the cloud for these advanced cyber manufacturing kind of businesses. So that's another industry we worked very closely, and we've done similar sort of brokering techniques for them also. In fact, this is happening for every field. And I had last few weeks back a major project we submitted for a AI Artificial Intelligence Institute that relates to agriculture. So a lot of the food agriculture businesses also. There's a lot of data. There's a lot of image data, sensor data. Again, they're going to the cloud to process to figure out how to do better drought-resistant crops, or figure out how they can manage their fields, how to manage their food supply chains. So again, every business is probably going to benefit if they're trying to do a lot of data-intensive, computational-intensive applications.
Thank you. And again, to the audience, if you have any questions, please feel free to type in the chat window. We are glad to take your questions. And before other questions, so Professor, is this project in open source, or if people want to start getting more experience with OnTimeURB, what should they do?
Yeah, so we are actually a year and a half into the project. This summer we have a planned open source release. And like I said, a lot of the research has been sort of tailored to the two communities of the applications. But we have a plan to make it a general software for people to try with. So yes, in summer I would expect we'll have an open source version that's available for everyone to try with a few examples and documentation.
And that will be posted on your website, ontimeurb.net?
On the website, yes. Yes, it will be posted on the website. And that's one of the requirements of our sponsor, is to have open source software. And again, we want to make it obviously state of the art, but also very much usable for people. So that's why we have a lot of usability studies also happening for both these systems actually. So if there's questions on how are we making this software usable, I would encourage you to contact me. I can connect you to my collaborator Isa's lab, so that she has a team of students looking into the usability aspects of how the software could be easy for people to do all the steps I talked about.
Great. So yeah, I don't see any questions, but if anybody has any more questions, please feel free. Before we close, I would just want to thank Professor Calyam for his time, and this is great research. I myself learned a lot from this presentation, and security performance is squarely what Aquila Clouds has been focused on, and Professor Calyam has been on our advisor board, and look forward to including many of these cutting edge technologies in our platform as well. For the audience, if you would like to follow us, Aquila Clouds, please, follow us on Twitter, LinkedIn, or Facebook. And then we will have more of these webinars on best practices for cloud deployments coming up. So come to our website, to our events page, and stay tuned. And we would like to have you in our community as always. Yeah, so thank you so much for joining. We will send out the recording shortly. And if you have any questions for us or for Professor Calyam, you have our contact information. Great. So that's all I have to say. If the participants do not have any more questions, we will conclude today's webinar. Thank you much for joining.